Hello everyone. So let us discuss today what is ultrasonic waves. Basically, in science there is one portion which deals with sound, right? The science of sound which deals with origin, propagation and auditory sensation of sound. So let us just see how we can categorize them. So there is sound production, there is propagation by human being or machines, and then there is a reception. So all this is either done by human beings or by machines. Based on that, we can say that entire sound waves can be classified in three distinct categories. Right, so the entire sound waves can be categorized into three different ways. First one is infrasonic, or it is also known as infrasonic waves. Infrasonic, right? So the word infrasonic waves are basically inaudible to human beings. The waves which are having a frequency which is less than 20 Hz are categorized under infrasonic waves. Now, after infrasonic waves comes audible waves or audible sounds. So, the audible waves or audible sounds are those sounds which fall under the category of 20 Hz to 20,000 Hz, right? All the waves of sound which fall under 20 Hz to 20,000 Hz are termed as audible waves or audible sound waves. And the third category is ultrasonic waves. So as we all know that we are here to discuss about ultrasonic waves. So what do we understand by ultrasonic waves? All those sound waves which has frequency more than 20,000 Hz are termed as ultrasonic waves. So basically there are three categories: infrasonic waves, audible sound waves and ultrasonic waves. Infrasonic and ultrasonic, both the sound waves are unaudible to human beings, right? We cannot hear them, so they are inaudible to human beings, whereas we only have audible range from 20 Hz to 20,000 Hz. All the frequency or all the vibrations of sound which falls under the category of or which falls in between 20 Hz to 20,000 Hz are audible to human beings. Now, infrasonic and ultrasonic are inaudible to human beings, right? So, the example of infrasonic sound wave is waves which are generated by earthquake. We cannot predict or we cannot listen to the sound wave generated by earthquake, right? So that is a example of infrasonic wave. When we talk about audible wave, we all know that each and every sound around us which we can hear are audible waves, right? And talking about ultrasonic waves, so all the ultrasonic waves which can be heard or which can be sensed is fall under those category, right? So all the waves which are having higher frequency than 20,000 Hz fall under that category, and ultrasonic waves can be sensed or heard by few animals or birds such as bat, dog, dolphin, whales, some different birds, right? So all those creatures of nature can hear or actually sense ultrasonic waves, right? So let us move now. Let's talk about properties of ultrasonic wave. So there are numerous properties of ultrasonic wave due to which we are using ultrasonic wave in our day-to-day life for various types of communication, for various type of collecting information and so on. So let us just see what are those properties which make this ultrasonic wave so special, right? So the first and foremost important property of ultrasonic wave is that they are mechanical wave, right? So they need medium to transfer, or they need material medium to propagate from one part to another part. So that's why we call them as a mechanical wave, because they need a material medium to travel. Then comes the second property, which is they offer the resistance will be offered by medium to propagation of ultrasonic wave, and that is known as acoustic impedance, right? So acoustic impedance is nothing but resistance which was provided by that particular material medium during propagation of ultrasonic waves. So acoustic impedance can be given by rho into V. Now, velocity of propagation is directly proportional to physical properties of material. So V square is equivalent to E by rho. The difference in elastic modulus of material are higher than those of density. So V is determined mainly by using E, right? So elasticity is very much helpful here. Now ultrasonic waves undergo reflection, refraction, scattering and diffraction as light waves, right? So if you compare light wave and ultrasonic wave, they behave quite similarly, right? They also undergo, right? Just like any light wave, ultrasonic wave also undergo reflection, refraction, scattering and diffraction. All these four phenomena are also performed by ultrasonic wave. Now, ultrasonic wave get attenuated while traveling through medium. That means A is equivalent to A0 e raised to power minus alpha x, where x is our distance traveled and alpha is attenuation coefficient, right? So it will be an attenuation coefficient. And A here will be the amplitude of the wave. How much high amplitude is there will be shown using this particular formula, right? The more high amplitude, more will be the frequency. So using this we can determine. Now, talking about few more properties, the frequency of ultrasonic wave is greater than 20,000 hazards or 20 kilo hazards, right? The next thing which is very important to know and remember according to ultrasonic wave or with respect to ultrasonic wave is that their wavelength are smaller, right? They have very small wavelength. So as a result, penetration power will be very low. When you have a smaller wavelength, you cannot penetrate so easily from one medium to another. That's why due to smaller wavelength of ultrasonic wave, the penetration power is quite low. Then they can travel over long distance as a highly directional beam. They can travel over a long distance as a highly directional beam because they travel through a material medium. So if you are providing it a proper material to travel, it can easily travel for a longer duration. Then they have a high energy content. Obviously, since the frequency is so high, so there will be a high energy content inside the ultrasonic waves. The speed of propagation also increases with increase in frequency, right? So these are very much important properties of ultrasonic wave, and we must remember the basics of ultrasonic wave, the basics of sound waves, right? So sound waves are basically classified into three categories: infrasonic, audible and ultrasonic. Infrasonic waves are those waves which have wavelength less than 20 Hz. Audible wavelength have a wavelength or frequency in between 20 Hz to 20,000 Hz, and all the waves or all the sound waves which are having frequency greater than 20,000 Hz or 20 kilohertz are termed as ultrasonic wave. The most important part of this entire ultrasonic wave is that they need material medium to propagate, and they also show same property as of light, like diffraction, reflection, refraction, right? So they also do all that kind of activities just like light. So I just hope the topic which we have covered today is quite clear, and anything related to ultrasonic wave or properties related to ultrasonic wave is very much clear, right? Once again I am repeating, there are basically three different categories of sound wave: infrasonic, audible and ultrasonic. Infrasonic is inaudible to human beings. Audible sound waves are those waves which falls between 20 Hz to 20,000 Hz, right? All the sound frequency which falls in between 20 Hz to 20,000 Hz are audible to human being, and we term them as audible sound waves. Then come the third one, which is ultrasonic wave. Ultrasonic wave is again inaudible to human beings. Ultrasonic wave can be sensed by few creatures, right, like dog, dolphin, few birds, etc. Right? So all of them can sense or can relate or understand that kind of waves. But we as a human being are not in that capacity which can understand, hear or sense the wave which are less than 20 Hz or more than 20,000 Hz. Right? So this is all about ultrasonic wave. One more point which we must remember is that they have very small wavelength, right? Their wavelength is very small, so penetration becomes quite a big problem, right? So the penetration power is low and it takes quite a big challenge to penetrate into different media. Now I hope this topic is clear. Thank you.